Alright, so if you made it here so far, we're at the third part of the pre-launch. The Prime Crew pre-launch checklist. This starts with ingress and status checks at about minus 2 hours and 40 minutes to the launch. So let us pull up the checklist, since here's another really long one, so I'd like for you guys to see the checklist. CDR ingress left-hand couch. We go suit power on, power audio tone, and then we will go ahead and turn on the two cabin fans. The LMP will now ingress the right-hand couch. Suit power on, power audio tone. We'll let the checklist run its course for a little bit. Oxidizer flow valve should be normal now. Command module pilot will now ingress the center seat. Coming down to the bottom, we go suit power on, power audio tone. Caution and warning to AC or acknowledged. The suit water accumulator auto will go to number 1. Uplink telemetry command will go to normal. And uplink telemetry command module will go to block. Lastly, pad comms to off for the CMP, just because they're next to two people with the pad comm on. It's kind of a hard switch to get, so having it pre-done for the CMP would be nice. The emergency detection system tests will be the next one to be performed. So on panel 7, EDS power to on, EDS auto to on. And now the space vehicle test conductor will start operating the abort system checks, and this will take about roughly 45-ish minutes. So you can go ahead and time skip down to T-minus 1 hour 55 minutes. Again, for most people, you'll have to be sitting here at 10x speed. If you have a pretty good computer, you could bump it up to 60x if you have your PCM bitrate set to low. That's very important. So we'll go ahead and time skip down. Okay, at T-minus 1 hour 55 minutes, we'll stand by for an abort light operation test. Yep, abort light is on. While we wait on that, we can go ahead and get the switches set off. So S-band, intercom, and VHF will go to off for the commander, so that they could test or talk to the space vehicle test conductor. And then pad comms off for the LMP so that the LMP doesn't hear the space vehicle test conductor constantly talking to the CDR. There we go. Board light operation is verified. You can now go ahead and time skip down to T-minus 1 hour and 40 minutes. We can see the different Q lights actually come up. We saw a flicker on those launch vehicle lights, launch vehicle rate. The last one would be the launch vehicle guidance, which may have actually already happened. But it's a full checkout of the emergency detection system, so each light should come up, most importantly being that abort light. At T-minus 1 hour and 40 minutes, you can close the hatch. It's really hard to know where the hatch click point is because the boost protective cover is covering our view of the outside because it's not yet animated. So if you go ahead and just click the EXEC button until the hatch starts to close, and then click it again until it turns off, because no cheating. No cheating allowed. And then actuator handle, select the middle position for neutral. You do need to update your view like that by going left and right to get this click point to work there. So if you're wondering why I do that every time. Next procedure at T-minus 1 hour and 35 minutes will be a launch azimuth change if required. It will not be required. And we can set cabin fans to off. At T-minus 1 hour and 21 minutes, our space vehicle test conductor will complete the closeout, or will have a closeout of the emergency detection system test. We get a small master alarm there for a split second. We'll just see we've got CO2 partial pressure, most likely. Let's go ahead and check. Yep, CO2 partial pressure, so we'll go ahead and not time skip so fast. We'll just go slow from now on. Yes, time skipping with the hatch closed can cause the CO2 to accumulate, so if you ever get that alarm, just, stop your high time acceleration and just go back to 10x as the maximum rate. And it will eventually sort itself out. You don't want to keep high time skipping, otherwise you'll obviously kill the crew, so. Yeah, usually doesn't happen, but sometimes it does. T-minus 1 hour, 21 minutes. Our space vehicle test conductor has completed the test, so we'll go ahead and activate the rest of our comms. And we'll go ahead and deactivate the emergency detection system. At T-minus 1 hour, we'll have our guidance and control verification checks. We'll start with just ensuring uplink telemetry on our instrument unit is blocked. And we'll go ahead with the gyro power up for our body-mounted attitude gyros to measure the spacecraft rate. Rates accumulated in roll, pitch, and yaw. Again, going slow just because of that CO2. Here we go, we're approaching the time now, T-minus 1 hour. Verify that our BMEG temperature lights are not on when we set caution warning to normal. FDAI GPI power to off so we don't get any potential ball drift when we go and power up the BMEGs. BMEG 1 and 2 to on. FDAI GPI power to both. And then we verify that the BMEG templates don't come on when we turn them on as well. If we don't get any alarms, we're clear to go back to AC. GDC align, so we'll set FDAI select to switch position 1. This activates the primary ball only, turning off number 2, but it allows us to use our GDC on ball 1. Source to attitude set. We can see it drives back to 0 because our GDC, our gyro display coupler is not aligned. So we verify 152, 90, and 0, and we push and hold GDC align. Once the ball stops moving, go ahead and release. Set roll to 158, pitch to 81, and yaw to 355. We should see error scale in full up, full right, and full right. Go ahead and select ball 2. We should see ball 1 turn off, with ball 2 slewing to the same position that ball 1 had. We will push and hold, verifying we can do the GDC align on ball 2. Then go back to 152, 90, and 0. We should see full left, full down. Selecting ball 1, we should see full left, full down. And then a final push of the GDC align, just to get back to that launch attitude alignment. We'll now do the gimbal drive and trim check, so that requires the batteries to be turned on. As you know, using the SPS pitch and yaw needs the batteries to be on because they're tied directly through batteries A and B. So TVC servo AC1 main A and number 2 to AC2 main B. Primary TVC check, so pitch 1 start. You want to hold all momentary switches for at least 1 second. Yaw to start. Trim check, so -1, +1, and 0, -1, +1, and 0. Go ahead and perform a manual MTVC check, manual thrust vector control. So pitch down, center, pitch up, center, yaw left, center, yaw right, center. And since you all are new, attitude controls for the spacecraft are 8 and 2 being pitch up and down, 1 and 3 being yaw left and right, 4 and 6 being roll left and right, respectively. We'll do our secondary test, so SCS thrust vector control will go to auto. We will start pitch 2, yaw 2, and we will enter the manual control mode. So left is the abort mode, right is the manual control mode, as I like to call it, but it actually just engages SCS. So turning that knob ignores the spacecraft control switch from CMC to SCS. It manually engages SCS. You can use that to manually engage SCS auto hold during a burn. However, in this configuration, it will actually do the complete manual takeover, which it is set up to do for most burns when you turn that handle. Since otherwise, you could just flip it to SCS and it'll do its auto hold. There we go. All right, same thing. Pitch down, center, pitch up, center, yaw left, center, yaw right, center. Now we'll do the auto switch over check. So turning off pitch 2 and yaw 2, we will verify that we don't have any manual thrust vector control on 8, 2, 1, and 3. Good. THC can go back to neutral. And then we'll set the launch trim, which is -1 and -0.5. Thing to note, using left click gets you 0.5, right click would get you 0.1. Pitch 1 off, yaw 1 off, and then the main batteries, main bus ties for the batteries will go first to off and then to auto. So auto takes the last mode, and then we'll set it to the other mode if required. So for example, if you had it on, then auto, it would stay on and maybe turn off if required, whereas if you set it to off and then auto, it would turn on when required. So off, then auto, that's really important. DVC servos, we can turn those off. And then the launch vehicle indicators, we can go back watching our fuel and oxidizer pressure. Alright, FDAI verification, we'll go back to 1, 2. Verify they both display the same thing. Very good. Source to CMC. Now we'll do our RSI test and setup. So EMS roll to on. You click, left click, hold shift, and then release left click, and then release shift. You can press and hold the GDC align. And then you'll go ahead and yaw through 45 degrees. I use an auto clicker, so it's perfectly done by 1 every time. But you can hold left click and it'll go by 0.1 every time. There we go. Verify that is pointing at the 45 degree mark and bring her back down to 0. We can see that's pointing straight up now. Release. EMS roll off. At this point, we'll need to align the GDC to the IMU if required, just because of some drift from, wind and stuff when we did that GDC or that RSI alignment. Wind can drift us, so we get a little bit off in our GDC. So going ahead and nulling those errors out. There we go. We'll talk more about GDC align a little bit later, but if you just follow that same basic procedure, select one, attitude set, flip attitude set to IMU, use these knobs to center your yellow needles, and then push the button. If you get it where it's super far off, it's because it's 180 degrees around. Shouldn't be possible during the launch though, because you pretty much know that this is going to be about what you'll see, so. Delta V set. And you can set this to 2,000 feet per second. And left click to Delta V. And the next thing will be enabling pad abort capability at T-minus 30 minutes. And we can see our CO2 partial pressure has finally stabilized at its nominal value, so we can go ahead and increase our time skipping a little bit, and we can see that that does slowly begin to rise. So as soon as it gets to about here, we'll go ahead and do back to 10x speed. There we go. 30 minutes. We'll enable pad abort, so emergency detection system power on. Sequential events control system, plug in all your circuit breakers. Logic on first. In real life, they would give you a go for pyro arm. You would pyro arm. Command module RCS logic on so that the abort system can engage a propellant dump. And that is all that's required. Now, if you go to the abort mode, you will have a pad abort at this time. We can see tower's fallen back. And in the back right there, we can actually see our overall objective for the Apollo program. Coming down to T-minus 20 minutes. Slowly again due to the CO2 partial pressure. Looks like we could do just a little bit of a bump on some high acceleration here. There we go. 20 minutes. So we'll go ahead and activate service module RCS. Starting with the helium 1. Open all of these isolation valves. Verify 4 grade talkbacks. Now helium system 2. Open all 4 of the isolation valves, each responding to an individual quad. So we have A, B, C, D, and quads A, B, C, D. Verify good helium pressure. So here, helium pressure is here. All 4. Good pressure. We'll go ahead and close the secondary propellant fuel pressure. Now notice we don't get any talkbacks for secondary propellant, and that is because we only get talkbacks if there's actually propellant flow. So in order for the secondary to work, the primary needs to work. Because we have no talkback indication of a secondary propellant, we need to basically close those before opening the primary. Even if they might already be closed, anytime it tells you to close them, you gotta close them, because there's no indication of those isolation valve positions. Now we'll go ahead and open a primary, and you can see we've got talkbacks. All 8 talkbacks are gray. Verify good fuel pressure here. Now we'll do the service module RCS hot fire test. So RCS command on, momentary switch, so make sure you hold it for a second. Now we'll go ahead and activate Charlie 3 on main A and Alpha 4 on main A. We'll go pitch up, pitch down, just one pulse. If you hear the valve actuation and a gas fire, you're good. Now, we'll test Delta 3 and Bravo 4 on main B. Yawing right, then left, or left and right, that is. And then we'll go ahead and set all of the switch positions to the nominal mode. So this would be up, down, up, down, up, down, up, down, down, up, down, up, down, down, up. RCS command goes to off. Now we'll do roll left, roll right, pitch up, pitch down, yaw left, yaw right, just verifying no firing. Good. Manual attitude pitch will be Excel command, and we'll do for this checklist our final GDC align of the checklist, and we could see it's actually really good already, so there's no reason to do the GDC align. We check that by going select 1, source to at set, and clicking the at set switch up and down and just seeing how the ball moves, and we can see it's barely moving at all. So now we go source to CMC, select 1, 2, and make sure that at set remains on GDC the entire time, basically. Unless you're doing alignment, then you go to IMU. Otherwise, it must remain on GDC. That's very important. BMAGs, we will select rate information from BMAG 1. So that's the down position here. And that completes this very last pre-launch checklist. The very last checklist we will be performing prior to launch is the launch checklist, followed by boost. So I guess it's really pre-launch, but you're getting everything good for the launch. And so we'll probably do the launch in that video, but just know that every launch is different, so don't follow that as a guidelines for launching. You can follow it for an Apollo 7 mission, but that's about it. Every launch is different, but we'll just do it anyways, just because launches are fun. We've all worked this hard, or, well, if you don't have the sim, you've all watched this hard, and I feel like you could enjoy a little launch, little reward for all the work we put in. So I'll see you guys at the next one for the last checklist and coming up to launch.